This video will cover using conditional expressions in data wrangling. The code used in this video is available on the Learning Management System. It will use the data file weather2017.rds. You should download these now if you'd like to follow along. By the end of this video, you should understand what a conditional expression is and how you can use R commands to perform conditional expressions. In the data wrangling process, we've used mutate to create or modify variables. It evaluates expressions for each observation in the dataset and saves the resulting value to a new or existing variable. Often, you're going to want to perform these types of operations only on a subset of your data. For example, compute a certain expression when certain values in your dataset are above 0, or change some text only when it was entered incorrectly. As a motivating example, suppose that you'd like to compute a daily deviation from average temperature, but you want to do it in a special way. From January to March, you want to subtract the minimum daily temperature from the average, but for the rest of the year, you'd like to subtract the average temperature from the maximum. How would you go about doing this? In R, you can accomplish these tasks with conditional expressions. These are functions that evaluate different expressions depending on the outcome of a logical test. dplyr provides two major functions for conditional expressions. The first, if_else, decides between two possible options, and then case_when decides between many possible options. We'll start with if-else. Again, it's a conditional expression to evaluate between two possible options. The way it works is you specify three arguments. The first is a logical expression returning true or false. The second argument is an expression to evaluate if the result of that logical test is true. And the third argument is an expression to evaluate if the result of that logical test is false. Thinking back to that motivating example I gave you, if you'd like to compute the deviation from average temperature in two different ways depending on the time of the year, you might think of using this flowchart where first you say, is month less than or equal to 3? Those are the January, February, and March months. If so, then you're going to compute the deviation as the average temperature minus the minimum temperature. But if not, then you're going to compute the deviation as the maximum temperature minus the average temperature. I can implement that using the R code that I have on the right-hand side. Again, I'm going to take some data, pipe it to a mutate verb because I'd like to change or create a variable. I'm going to create this variable dev. I'm going to use a conditional expression, if_else. First, I provide the logical test where I say month is less than or equal to 3. If that test is true, I'd like to compute the value as average minus minimum. But if it's false, I'd like it to compute it as maximum minus average. Let's take a look at this in R. First, I'm going to run my setup code. Now let's look at that if-else expression that I had in the slides. I've changed the variable names to match what I have in my data. So again, I'm going to take the weather data, pipe it to a mutate verb, because again, I'd like to create or change a variable. I'm creating this new variable dev, and it's going to be equal to, again, the if-else conditional expression. Then I provide the logical test. Here I say month less than or equal to 3, which will be true for January, February, and March. Then I provide the expression I would like it to evaluate if that test is true, which is average.tempf minus minimum.tempf. Third, I provide the expression that I would like it to evaluate if that logical test is false, maximum.tempf minus average.tempf. I can go ahead and run that code, then look at the output. In that resulting tibble, you now see I have a column dev. You only see observations for January in this limited output. You can tell that it is average temperature minus minimum temperature. The second major conditional expression is case when. This allows you to decide not between two options, but between many options. The way case when works, again, you specify the case when function, and then you're going to provide pairs of tests and expressions separated by a tilde. You can provide as many as you like, separating them with commas. The way R is going to handle this is it's going to look at each test in order, and it's going to evaluate the first expression where the corresponding test is true. After that, it won't pay attention to anything else for that observation. If it gets all the way to the end and none of those logical tests were true, it's going to return NA. Again, case when will go through each of the logical tests you specify, one at a time, and it's going to evaluate the expression and return the value of the first case where the logical test is true. This allows R to select from many options. But remember that if no test is true, it's going to return NA for that observation. Frequently, it's a good idea to put a catch-all test at the end of your case when to ensure that you never get an NA value resulting from your case when. How would you actually do this in practice? So after you write all of your logical tests in a case when, you include a last test, which is just the value true. And then as the expression, you have the default value that you would like to come out if no other expression matched. True will always return true, so that logical test will always be true. And if no other logical test matches, you'll get that default value. So we'll use case when to implement similar logic to what we did with if else. But here instead, I'll change the scenario a little bit. Suppose that we'd like to compute this deviation from average as average temperature minus minimum temperature in January, February, March, November, and December. Now we have 2 sets of months, and the simple logical test less than no longer is sufficient. Here I have this as a case when statement. So again, I take my weather data, I pipe it to the mutate verb. I specified like a variable dev equal to the conditional expression case when. In the first case, I say month less than or equal to 3, and then I provide the expression I would like evaluated in January, February, and March, which is average temperature minus minimum temperature. Then I have a second case where I say month greater than or equal to 11. This will be November and December. Again, that same expression, average.tempf minus minimum.tempf. Then lastly, every other month, I would like to be computed as maximum tempf minus average tempf. So I just specify true. If R makes it that far, it will just always evaluate that last expression. Let's go ahead and run that code, then look at the output. And as you can see, once again, my resulting tibble now has a dev column. You only see observations for January in this output, but again, it is calculated as average tempf minus minimum tempf. You can create much more rich conditional logic with case when. Remember, you can specify as many logical tests as you would like. For each observation, R works through them one at a time and evaluates the expression for the first that is true. Both if else and case when provide conditional logic that make it easy for you to manipulate subsets of your data.